All right, this video is for Stat 210, Handout 9, Part B, and we'll cover pages 10 through 16. Okay, let's go ahead and get started. We will again be using the U.S. counties demographics data, which can be found in our Google folder. We'll be looking at Part B here, which considers the measures of spread. We are going to continue looking at the Minnesota household income levels in the United States. But here, what we want to consider is the notion of income inequality, or the wage gap. And what we mean by the wage gap is that some Americans are getting richer and the rest of us are not. Okay, so there's a gap in salaries between the most affluent Americans and then the others. So what we're interested in when we want to gauge or measure income inequality is not necessarily how high the incomes are within a state, but how condensed are the incomes, or how compact are the incomes. So it would be okay, for example, in Connecticut, if the income was $74,500, just so that everybody in Connecticut was making that amount. They would not have an income inequality problem if everybody in Connecticut was making the same amount. So what we're actually concerned about is not only just a shift, but also how condensed or spread out is the data. So if we have a state here like Virginia that has high income inequality, in other words, in Virginia, the incomes are kind of all over the place here. Okay, if we zoom in on that a little bit, for Virginia, you can see that the incomes are spread out a lot compared to Connecticut. Try that. Can't get a box down there, but Connecticut's income is fairly compact compared to Virginia. And Minnesota is kind of somewhere in between there. So if we are interested in how compact the data set is, or data is, we're not interested in position, but we're interested in the notion of spread. Now, the notion of variation exists in things like stocks as well. So here I just grabbed something easily off the web here, where just the stocks are pretty even here, and then they start going crazy. In this part here, okay, in this initial part, the stocks have a steady price, which means less variation. And if I'm buying stocks or selling stocks, that means less risk. After a while here, though, the stocks really start moving all over the place. That means more variation or more risk. So this notion of variation is important in lots of different contexts. Okay? So how do we measure that? What are our measures for spread? Well, the first one is very naive, and it's not a very good measure at all, and that's simply the range in my data. So the range in my data simply goes from the smallest value up to the largest value. So this is our Minnesota data set again. Let me go over and create those summaries real quickly. Here's my Minnesota data that has the 87 counties. Just underneath Analyze, Distribution. Again, I'm looking at income. I'm going to want to hit Stack here to turn it on its side. And there's my quantiles again. I talked through these in Part A of this handout. So the range here is simply the largest minus the smallest. And for this data set, that range is about $50,000. So between this poorest county in Minnesota and the richest county in Minnesota, there's a difference of about $50,000. Now, why is the range not a very good measure? Or why is it a measure not used by statisticians? The reason is it only uses two values out of your entire data set. So when I'm trying to figure out how spread out this data is, I'm only using two values here, the smallest and the largest. Furthermore, the range actually uses the most extreme values in its calculations. So therefore, it's going to be highly influenced by outliers. If this observation here, one of these observations here, jumps up a little bit, that's going to certainly influence the range. So we consider the range to be a terrible measure of spread. A, because it only uses 2 observations, and B, it by definition uses the outliers in its calculation. So a second measure of spread is something called the interquartile range. Now, this is actually invented and used when we construct box plots. And it's a measure of spread that is like the range, except it's not influenced by outliers. So how do we compute a measure of, or how do we compute range and it not being influenced by outliers? Is what we do is we don't compute the range from the smallest to the largest, but we compute what's called the interquartile range, which is just the range between the 75th percentile, Q3, and the 25th percentile, Q1. And that value is about $8,500 here. Now, what this value actually tells us is it simply tells us how condensed the middle 50% of the data is. Now, one thing that the IQR does not concern itself with are these other observations that sit outside of the interquartile range. So it does give me a measure of spread, but it's only doing that for the middle 50% of the data. So what do statisticians use as our measure of spread? What we use is the standard deviation. And the standard deviation simply looks at what is the distance between an observation and back to the mean, or up to the mean. So here's our Minnesota data. I have all of the different counties here. I've just drawn in a bunch of red arrows to show you the distances to the mean here. What is the average red arrow length? That's what standard deviation is. I think the standard deviation here is about 10,000. So the average arrow length is about 10,000 in this picture. Now, this notion of measuring the distance back to the mean is something that we used in a chi-square test as well. And this idea is common in statistics. We do that quite often when we're trying to measure variation or disparity, as we worry about that distance back to the mean. Here's what that formula looks like for the standard deviation. I simply need to take the data point minus the mean. I have a square in here. As you might anticipate, like the chi-square test, when we were talking about that, if you don't put the square in there, all of the positive distances are going to cancel out all the negative distances. You can either use a square in here, or you can do an absolute value. But the standard deviation does the squaring. Now, when I do the squaring, so I take these arrow lengths and I square them, that's going to mess up the scale, certainly. So if I take from like this 90,000 back to the 60,000, whatever that is, 55,000, that's going to be 30,000. That arrow length is 30,000. But then I square that here. And that's going to become a very, very large number. And I do that. I add up all of those arrow lengths squared for all of the data points. So that squaring messes up the scale. So what we do to compensate that is just take the square root at the end here. So this middle part is kind of like an average squared distance, but then I take the square root of it, so we can think of the standard deviation as the average arrow length, kind of the average distance to the middle. Now, if all the data values are really, really close to the mean, then the red arrow lengths are going to be very short, and the standard deviation is going to be close to 0. The smallest possible value for the standard deviation is indeed 0. If I get a standard deviation measure of 0, it means that your data has no spread in it. And the income levels across the state would all be the same. So states that have a small standard deviation in this context are states that are going to have a low income disparity problem. Standard deviation can be found underneath the summary statistics. And again, it's just that average distance to the middle. Now, there are other measures that people have come up with other than standard deviation that still involve this kind of typical or average distance to the middle. One of those is called the mean absolute deviation. The mean absolute deviation is just going to look at how far away are they from the mean, but instead of squaring, it's actually going to take the absolute values. It's still going to add up all of those and divide by n here. The other thing that we could do is look at how far away is the data point from the median instead of the mean over here. So if I have outliers in my data set, I know that my average is going to be messed up with those. So maybe I don't want to use a measure of spread that uses the mean, either one of these, if I have outliers present. The median is going to be more robust against that, as we talked about in Part A. Now, if I have a whole bunch of those arrow lengths from the median, why not just take the median of all of those? So that would be called the median absolute deviation. This measure on the right, it feels like it'd be much more effective if I have outliers present in my data. Now, this one over on the right is not very common. I mean, it makes sense to me to do something like that. JMP actually has that available to us. You have to hunt for it inside of JMP, but it's certainly not very common. Let me show you real quickly where that's at before I forget. So the median absolute deviation can be found underneath the red drop down for summary statistics. I can do some customized summary statistics. And the one here is the median absolute deviation. So my median absolute deviation here is about 4,000. So for the Minnesota data, household incomes, it's about 4,000. Now that's quite a bit different than what I got from my standard deviation. Again, one main reason that we compute these quantities is so that we can make comparisons. We can do that either with standard deviations, or we could do that with something that's a little bit more robust, like median absolute deviation. Or you could use this one over here. So here I computed the standard deviation for Virginia, Minnesota, and Nebraska. The number of rows here is simply just the number of counties in each of those states. So as we talked about above, Virginia has more spread in it than Minnesota does. And this is income levels across the counties again. So Virginia's average distance to the middle is about 20,000. It's actually pretty large. Minnesota is about half that at about 10,000. And then Nebraska is really kind of tight. Their income levels are pretty similar here. They're the most compact or most condensed. And their standard deviation is only about 6,600. So the standard deviation for Nebraska is about 6,600. That is the average distance to the mean for all the counties in Nebraska is that $6,600. The standard deviation for Virginia is going to be quite a bit larger here. So Virginia has more income disparity problems than Nebraska does. Minnesota's kind of in between there. So these arrow lengths here are actually called, let's go back here. These arrow lengths are actually called deviances. So how far do I deviate away from the middle? They're sometimes called residual values or even error values sometimes. So what I did here on this map was looked at all of those deviances. Do they counties tend to be negative or do they tend to be positive? Do those deviances tend to be negative or do they tend to be positive? Now, if they're negative, that means they're going to sit way down on the lower end of this distribution. These are going to be negative deviances here. And positives are going to be way up here. In that map down below, the ones that are really, really high are going to be green, and the ones that are really, really low are going to be red. So in Virginia, these counties that sit right around D.C. here, so D.C. is right up here in the corner, those incomes are quite a bit higher. Those counties have a residual or a deviance that is much higher than the average. The poor areas of Virginia are way out here. This is next to eastern Kentucky and eastern Tennessee. This is a very poor area here. This is where all the old coal mines are. Those people out in those areas are very, very poor. Certainly compared to kind of on average, but also very much poorer than the richer areas in Virginia. If you look at Minnesota here, you can see the Twin Cities here. Twin Cities tends to be a little bit more green than the other parts. And again, the income levels there are higher, tend to be higher than what a typical income is in Minnesota. In Minnesota, we have some counties up here that are pretty dark red. These counties up here tend to be much poorer than the average county in Minnesota. So I'll show you how to do some of those maps down below. Before I do that, let's go ahead and create the information that's necessary to make the map. And what I'm going to do here is compute the standard deviation for all of the states. Okay, so JMP's going to do a lot of work here for me. So how do I do that inside of JMP? I need the big data set that has all 3,220 rows in it. I'm going to go under Tables, Summary. I'm going to do an analysis on household income. And what I actually want JMP to calculate is the standard deviation here. So let me show you that one more time. Household income and select standard deviation. I want to do that by state. So I need to put state here in the group box. What that's going to do is create that table that has the standard deviation of incomes for all the states. Now you can see that DC is actually missing its standard deviation, and the reason that is because it only has one value. DC only has one dot. So I can't really think about, that really doesn't make sense to talk about spread away from that one dot. Now what I want to do is sort these from the largest to the smallest. So I can select Tables, Sort. I want to sort by those standard deviations. And I want to put those in descending order. And that's the table that I provided in the notes there. Maryland, Virginia is really high. New Jersey actually is pretty high in the standard deviation. So these states up near the top have a problem or an issue with income disparity in those states. Minnesota here ranks 20th, I think it is. There's the standard deviation of about 10,000. As you might expect, Nebraska is way down here on the bottom. That's why I picked on Nebraska, because they have a fairly small standard deviation. Now, once I have this information, I'm going to go ahead and show you how to create the map quick. I'm going to go under Graph, Graph Builder. I'm going to select State and put that down here in the Map Shape box. And what that's going to do is create a map of the United States for me. Looks like I still have Nebraska highlighted. Just deselect that there. So the reason that map showed up is because I put state down here in the map box. Now I can just grab standard deviation and place that over the top of the map. You can change the color scheme by just double clicking over here on this scale. I think I picked something like this one here. So the red states here have high income disparity. The green ones have low income disparity. Say done again. And that's the map that I created there in the notes. So again, states like Nebraska, Kansas, Iowa, Arkansas actually have, Montana, Idaho, all have really low income disparity. Virginia, Maryland, really high. California's starting to get up there. So some parts of California are very wealthy, like around San Francisco. But if you get up into Northern California, there's a lot of farms and stuff like that, a lot of small businesses. Those aren't as wealthy. Those areas aren't as wealthy. Okay, that does it then for handout number 9, part B for Stat 210. Thank you.